In this video, we're going to take a look at the applications of sine and cosine having to do with the graphs. First thing we're going to do here with our data is we're going to draw a sketch of the graph. So you'll see I already kind of set up a nice grid. I'm going to put the time as my x and the depth as my y. And then to get the right graph going here, I'm going to use midnight as 0, and then go 2, 4, 6, 8, because it's 2 a.m., 4 a.m., 6 a.m. So that's how I'm going to label across the bottom. I'm just going to spread out my scale a little bit. You can do the same as I'm going to do. I'm going to skip every 2 boxes on the bottom and on the side. And if you need a minute to pause to just get that set up, the video, that's totally fine. Now I'm going to get the graphing part going. So I'm just going to plot all the points. You can kind of do the same as I'm going with this. All right, so what you're going to see at this point is we have a nice graph. It looks like a piece of a sine, a piece of a cosine graph. We got that curve going. And we're looking at the depth of the water with the tide. So the tides are going up, they're going down, then they're going back up. So it makes sense that it's going to follow what the sine and cosine graphs kind of do. Our goal is we're going to use this graph, and I actually labeled the max but not the min. Here's our min. And we can use this in a few different ways to figure out the vertical horizontal shift. So I'm going to do some work with the graph. The way we did this when we looked at our pictures is we counted the distance from the top to the bottom and then cut that in half and counted up from there. It's going to be a little trickier to do that here. So let's say I do that with the 11.3 and the 0 plus 0.1. Instead of counting, okay, so our total distance from top to bottom is 10.2. All right, if I cut that in half, that's actually going to give me my amplitude. Right, and that's a distance that we can count from either the top or the bottom to get our midline. So again, it's a little trickier counting-wise, but if I took 11.3 and subtracted 5.6, that would end up giving us our vertical shift line. So at about 5.7, not about, but at 5.7, which I'm going to approximate on the graph, That's where we have our vertical shift. I didn't quite make that straight. Now I did a lot of work here on the graph paper, which I'm going to transfer over onto the other sheet. So the order that I have it on the sheet's a little different, and there's other ways that you can do this, but I think finding the amplitude first is the exact same way we did the writing equation before. So you take your max y value, subtract off your min, and then cut that in half. Okay, so if we get that total distance, we cut it in half, that gives us our amplitude. And then if we take either the max or the min and add or subtract with the 5.6, so we could do 5.6 or we do 0.1 plus 5.6, that'll give us where the midline is. Or we can subtract it from the 11.3. Okay, so those are two important things, and when we're looking to write our equations down below, those are going to be the same for both our sine or our cosine graphs. And in this case, I find it's a little easier to use the cosine because we have our max and our min points. So I'm actually going to do two cosine graphs. It says to choose either sine or cosine. I'm going to do cosine. I'm going to start writing that. Now, because we have differences in our phase shifts, I have two different equations, a negative and a positive, and I also want to figure out what the period is. So the nice thing about having a max and min point is that's giving us half the period. We need to really get back to another maximum point to figure out the full period. Okay, so that would be my full graph. So where I have the red, that's half the period, and where I have what's in black, where I have my key information, that's the other half. So what I'm going to do is figure out the distance horizontally to figure out half the period, and then double that for the full period. So I'm looking at my x values when we're looking at that horizontal stuff. So half the period is going to be 10 minus 4. Which means our full period, if we double that, is going to be 12. Okay. And then we need to figure out what our b value is going to be. So just like we've done for the writing equations previously, we're going to set that equal to 2 pi over b. And we get a b value with pi in it, which you have seen before. So we have a b value of pi over 6. Fill that into the equations. And then we just have two different phase shifts. The positive graph has a phase shift of 4, so I would do x minus 4. And the negative graph, starting underneath, has a phase shift of 10, so I would do minus 10. going to do another video to talk about the back because it's going to be more stuff with plugging into our equations and then also using the graphing calculator. But that is going to be your technique. If you're given data, graph it first. Use your techniques for writing the equations from the graph. The tricky part is part D, since you don't have a full period of either graph to work with, at least in this situation.